Hello. What we're going to be taking a look at today is what I'm calling basic polynomial arithmetic. This is addition, subtraction, and multiplication of polynomials being put together. And the reason why I'm calling them basic is because they rely on techniques and methodologies that you've already seen in a prior class, most likely Algebra 1. And those would be combining like terms and distribution. You may have noticed that there's an absence of division. Division has several new concerns that we have when we're trying to divide polynomials, and so we're going to have to go over them another time. But combining like terms and distribution, let's review them really quick. So combining like terms is when you have terms that have the exact same variables with the exact same exponents and therefore can be combined. So for example, if you were to start with a polynomial that is not in simplified form, for example, x squared minus 3x minus 7 plus 5x plus 21x squared, you'll notice that there are two x squared terms, two x terms, and in this case a single constant. And we can rearrange those so that we have the x squareds, the x's, and the constants all kind of clustered together. And so we have 1x squared. Remember, there's an invisible 1 in front of any variable that doesn't have an explicitly written coefficient. So 1x squared plus 21x squared, which is 22x squared, negative 3x plus 5x, which is 2x, and minus 7. So when we're all done simplifying, we have this quadratic with three terms. Distribution is going to be what happens when we take a value or expression and multiply it by every term in a second expression. And you may be familiar with the FOIL process. Well, FOIL is really just a version of distribution. And you may notice that what we do here in a second is going to be a FOIL pattern. So for example, let's say we have two binomials that are being multiplied together. I can choose to take one of them, let's say the first one, and break it up into its two terms, x and the constant, negative 2. I can then take the x plus 4 and distribute it to each of the two terms from the other polynomial, from the other binomial. When I do so, if I were to write it out, I'd have the x term times the x plus 4 expression, then the minus 2 term times the x plus 4 expression, and I could then distribute each of those, and you'll notice again this is a first, outer, inner, and last pattern, so you end up with x squared plus 4x minus 2x minus 8, and when you simplify the 4x and the 2x, you end up with x squared plus 2x minus 8. Now, polynomial addition or subtraction are exactly like combining like terms. The only catch is you have to make sure that you deal with any subtraction or negatives or potentially anything that needs to be distributed before you can actually combine the like terms. So in this case, we have a subtraction. So we have to distribute that negative to the x cubed, x, and minus 6. And if we rewrite it this way, we can actually take out the parentheses now. So you're left with x cubed minus x squared plus 14 minus x cubed minus x plus 6. Notice that that negative distributes to the negative 6. That is a very common place that people forget to include the distribution, and it does make it a positive 6. Well, again, we can start grouping it based on like terms. I see a pair of x cubes, one positive, one negative. I see a single x squared, I see a single x, and I actually see two constants this time. So I can scramble them together, rearrange them, and you'll get x cubed minus x cubed, which does cancel out to 0. Negative or minus x squared, negative or minus x, and then 14 plus 6. So when we simplify it by combining like terms, canceling out the x cubes, and adding 14 and 6, we end up with negative x squared minus x plus 20. Lastly, we have polynomial multiplication, which is exactly like the distribution process we just saw. We just have more terms probably. And so if we had, say, a trinomial times a binomial, and we took the trinomial, broke it up into its parts, and distributed the binomial to each of those parts, well, we get something very similar to the previous time. And again, we have to distribute again in the next step because that x cubed has to be attached to the x squared and the minus 2. I'm not going to explicitly show that, but here we have the result of doing that. So x to the 5th minus 2x cubed, x to the 3rd minus 2x, and negative 5x squared plus 10. Again, you can combine like terms. It turns out there's only a single pair of x cubes. That's the only like terms we have. And so negative 2x cubed plus x cubed is negative 1x cubed, leading us to our result of x to the 5th minus x cubed minus 5x squared minus 2x plus 10. There's a lot of terms in these polynomials, so it's kind of a mouthful to say, but the process is exactly the same as what you were doing before. I hope this helped. See you later.